GCSE Physics boosters, massive stars. In the last video we talked about the life cycle of stars like our Sun. If a star has a much bigger mass, then its life cycle is different, and you need to learn that as well. Okay, this star here is represents a blue supergiant. Okay, and it's a much heavier star than our Sun. So there are lots of stars which are heavier than our Sun. If I say our Sun has a mass of 1m, then the very, very biggest stars have a mass of about 150 m. So 150 times the mass of our Sun. Now, if a star has a mass between 5 to 10 m, then it is a massive star, and its life cycle will be different. As it approaches the end of its life, it will be very, very different to what happens to our Sun. Here's a cloud. At the center of this cloud, there is a star, Eta Carini, and it is believed that its mass is about 150 m. So it's one of the largest stars that there is, Eta Carini. Let's look at this nebula, protostar, main sequence star, then red supergiant, not red giant, red supergiant, then supernova, then neutron star or black hole. So first of all, what's a red supergiant? Well, a red supergiant is just basically a very, very large red giant. Okay, a very large star becomes a very, very large red supergiant. In Orion, this is the constellation of Orion. It's dead easy to find in the winter. It's a fantastic constellation, loads of stuff going on in there. I've already talked about the Orion Nebula. And Betelgeuse, this top left, there's a star which looks red, or Betelgeuse if you like. In the constellation of Orion, that's a red supergiant, a very, very large red giant. Now, when the red supergiant phase is over, and we talked about the core of the star collapsing. Now, what happens is it does it very, very quickly because there's loads and loads of gravity. There's a massive amount of gravity, so it collapses very, very quickly. It gets incredibly hot, very, very hot, okay, up to about, I believe it's 100 million Kelvin. Okay, 100 million degrees centigrade, and lots of fusion takes place. That's important. I'll talk about that shortly. Tons of fusion takes place, and then it kind of rebounds. There's an explosion called a supernova explosion. What does a supernova look like? Well, imagine looking at part of the sky. Then all of a sudden, a very bright star appears from nowhere. And that star, that very bright star, is a supernova. And it doesn't last for very long. Gradually, it will fade away. It will only last maybe for a couple of weeks. And then if you look with a telescope, you'll see that there's a cloud of stuff which was chucked out from the supernova, from this explosion. And we know that in the middle of that, there's something very, very interesting. Talk about that later. But a supernova is a massive explosion. Okay, and then a very bright star appears and then fades over a couple of weeks. All of the elements that we are made of were put together in stars. Yeah, we are made of stardust. Or we're made of nuclear waste, take your pick. Okay, now after the Big Bang there was just hydrogen, because there was just like protons and electrons and little bits and pieces like that. And then when the universe had cooled down enough, these protons and electrons got together and formed hydrogen atoms. Then this hydrogen started to clump together and it formed stars, and we started getting fusion happening. And that's where the other elements come from. So all of the elements were put together, apart from hydrogen, all of the elements were put together by nuclear fusion. Now, very high temperatures are needed for fusion to occur. Because the nuclei are positive and they are repelling each other, to get them close enough together to join together, you need very, very high temperatures. In our sun at the moment, we're just basically getting hydrogen turning into helium. Later on, when our sun gets hotter, when it becomes a red giant, then we'll start getting more interesting elements. Okay, in fact, in red supergiants, we can get up to iron. So all the way up to iron in the periodic table. In a supernova explosion, that's where you get the heavy elements. Okay, so all of the elements in the periodic table are formed inside supernova explosions because it's incredibly hot. And then what happens is that those elements are chucked out into the universe. Okay, in the supernova remnant, it becomes a nebula, and then within that nebula, other stars are formed. So all of the elements that we are made of were put together in a supernova explosion, chucked out into the universe, and then that cloud, that nebula, became stars that basically one of them was our solar system. So, what happens when a large star collapses? Well, with a star like our sun, I told you we end up with a white dwarf. Okay? Now, with a larger star, the gravity is so strong that these atoms actually get squished together and you end up with a ball of neutrons. It's like a gigantic nucleus. It's very, very, very dense. It's called a neutron star. So the gravity is so strong, you end up with a ball of neutrons. Any protons turn into neutrons. Okay, this massive ball of, well, it's not a massive ball of neutrons. It's very, very dense. Okay, if you imagine a star which has, imagine the core has a mass of about 1.5 solar masses squashed into 10 kilometers. So imagine our sun squashed into about 10 kilometers. It has a very, very strong magnetic field, and they spin very fast, a few hundred times a second. So this very dense thing with a very strong magnetic field spinning around, okay, and emitting X-rays and other electromagnetic waves. This is how they were discovered. As they spin around and they're chucking out X-rays and radio waves and other stuff, we get flash, 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 flash. One type of neutron star is called a pulsar. Okay, we get this flash, 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 flash of electromagnetic radiation as it spins around very fast. This is called a neutron star. Then lastly, if the gravity is strong enough, so a very massive star, greater than 10 solar masses, if the gravity is strong enough, then the whole thing is squashed together, and even the neutrons are squashed into virtually nothing, into a point, a single tiny, tiny, infinitely small point with infinite density. And this point is called a black hole. Black holes are just a point mass with infinite density. And that sounds crazy, but that's what they are. The gravity of a black hole is so strong that even light can't escape, which is why it's called a black hole. Okay, it's a point mass with infinite density and incredibly strong gravity. When you see pictures of black holes, I mean, top right is a very famous image of a real black hole. When you see that black disk, that's not the black hole, that's called the event horizon. The event horizon is basically, if you get close to a black hole, if you get inside the event horizon, it's impossible to escape. Okay, so that's the radius, if you like. Inside that radius, it's called the Schwarzschild radius, nothing can escape. The black hole is actually just a tiny little point in the middle of that. Within our galaxy, there are lots of little black holes because there were lots of very, very massive stars which have died away. At the center of our galaxy, and perhaps at the center of nearly all galaxies, there is a supermassive black hole, a very, very huge black hole, or a very, very significant heavy black hole that all of the galaxy goes around like a whirlpool, a supermassive black hole. If you're interested in astronomy, I've taught GCSE astronomy and I've got a YouTube channel. And there's much more information on all of the astronomy if you want to check out that YouTube channel. Okay. So we've got there. This is the diagram. This is off the AQA specification, and it shows the life cycle on the left of stars like our sun, and on the right of stars much heavier than our sun on the right. And basically be able to draw it and be able to explain it. A typical question might be, describe the life cycle of a star which is much heavier than our sun, and there'll be loads of marks for it. Okay, so learn this diagram, learn the names of all the bits, be able to talk about each of them and what happens as you go from one to the other.